So Bohr diagrams are the next piece. We're going to use those configurations, and we're going to kind of basically draw a picture. That's what the diagrams are for, to show us where those electrons are. So one method, there's a couple different ways you can show electron location. The thing you got to remember, guys, is that all the electrons must be drawn. Okay? Kind of think about it as boring. I know this class probably seems that way a lot to you guys, boring just by looking at your faces. But Bohr, guys, and you're making rings with it. That's kind of the analogy there with it. Now, when I show you these, you might be thinking, oh, well, if we went down to the farther end of the periodic table where the elements are huge, they're not going to ask you to do that. Probably they wouldn't give you or ask you something beyond argon, which is number 18. Maybe potassium or calcium, but once you get into those other elements, guys, in our next unit we'll talk about what's unique about them, but they get really crazy really fast. So they're going to keep it simple for you guys. Basically, guys, what you're looking up is the electron configuration. All right? What does that term valence mean again? Outermost. Right, absolutely good. So that's a key word you guys need to memorize. All right? It's the outermost electrons. Okay? We know that if we're working with ions, we're going to add or subtract those. So, for example, oxygen is 2-6. Okay? So, if with that valence, if we have those ions, you're adding or subtracting that to your valence, which is your last number in the configuration. So, how many valence electrons does oxygen have, for example? 6. And we'll see another pattern when we get into our periodic table unit. We'll come back to that. Step 2, guys, is you're going to draw a square. You could draw a circle if you want to represent the nucleus. It's up to you. I'm not going to mark you off if you draw a circle or a square. Put a P there for the number of protons and an N for neutrons. You're going to tell me how many of those are, how many particles are in your nucleus. Then you're going to draw rings. Each ring, guys, represents an energy level. So yesterday, let me just ask you this. Oxygen. Looking at that configuration that you're given right here, how many energy levels does oxygen have, do you think? 2. How do you say that? Because there's a dash, right? So wherever you see a dash, guys, those numbers represent an energy level. That's how many rings you would have. So oxygen would have 2 rings around it. Okay? Then we're going to look at the first number. We're going to put an X or a dot. You'll see me do it both ways. When we do bonding, I'll do one with an X, one with a dot. You'll see why when we get there later. To represent the electrons. Place that many electrons, guys, in the orbit that's closest to the nucleus. Then you keep building up from there. So instead of me just reading through everything, guys, let's go through and do a couple examples. You're going to find this is pretty simple. So here we go. Carbon. First things first is you're going to give me the electron configuration for carbon. So find carbon on your periodic table. What's the configuration? 2-4. Awesome. How many total electrons does carbon have? 6. So we should have how many dots in our final picture? 6. Okay, we're going to show all 6 of those electrons. So the first things first, guys, in the middle, draw either a circle or a square, whatever you feel comfortable with. That's your nucleus. So we got to put in there how many protons and how many neutrons we have. How many protons? That should be easy. 6. How do we know that? It's the same as our... It is. And where do we get that number from? Atomic number. Good. Now we know that it's going to be the same as the electrons. Why? There's no charge, meaning this is a neutral atom. Good. You guys know more about this, even though you say you don't have confidence in yourselves. All right, neutrons. How do we figure out the number of neutrons? Yeah, we're going to subtract. Now, do they give us a mass number, guys, in this name? So what do we do to get the mass? We will round. Good. So that's going to be what when we round it? 12 minus the number of protons. So how many neutrons will we have? All right, piece of cake. So that takes care of our nucleus. How many rings should I have around my diagram? 2, because I've got 1 here for those 2 and then 1 there. So look at the dashes. How many you have? So draw 2 rings around it. The best you can, obviously. Mine are not great circles. Yours don't have to be perfect circles either. So, first ring has how many electrons? 2. Ooh, which is it? It's going to be 2. So, guys, we will pair those 2 up. You will see me kind of do the same type of pattern when I draw my electrons. Okay? So we've got 2 electrons on the first energy level. How many on the second energy level? We've got 4. Now you're going to see me do this way, guys. Again, it goes deeper, kind of with that S and P stuff we were looking at yesterday. If you were to go back and look at that chart I said not to worry about, we always filled the S in first with 2. Then we moved on from there. So we're going to continue that same pattern here. I typically will say the top, I'm going to fill in the top 2 first. Okay, pair those up. Then, if you went back to that chart, and I know this is where people got confused because we were doing arrows. They don't really look like electrons, so it got really confusing. We're going to now spread out our electrons. The analogy, guys, I use is this. If you came into this classroom and there were only these 3 desks in the front, okay, you didn't have places to sit. Okay, nobody said you had to sit anywhere. Somebody sits here, and you come in, you're the next person. Would you sit next to that person, or would you typically go to another one? Say it's somebody you don't like. You go to another one, okay? Most people, guys, and you'll find this out, throughout life when you have the option to sit wherever you want. If you're walking into a room and you don't know anybody, you're probably not going to. Most people are not going to sit next to somebody if they're already sitting. They're going to spread out, okay? Electrons are kind of the same way. That's an analogy. If somebody's sitting here at this table, probably going to move to the other one. At least that's me. Maybe other people can relate to that. I don't know. Just listen to the analogy, guys. Most people would spread out, and then when they have to go back and double up, they will. So what I want you guys to get in the habit of doing with these diagrams, the first 2, they're going to pair right up. Then, after that, they're going to spread out. So I'm going to draw one of my other one and my last one like that. This will come in handy again when we get to bonding later on. So we're taking it piece by piece. Did I show all of my electrons? Right. How many dots should I have? 6. How many do I have? 6. There it is. That's a Bohr diagram right there. Any questions with that? Easy? Okay. What's different about my next example? Oh, I have an ion. First off, what type of ion is it? Negative, which is called an... Oh, you know what I forgot to do with you guys, didn't I? I completely forgot the vocab quiz. We're going to take it in just a second. Completely forgot. Yeah, you guys thought I was going to forget, didn't you? There's the thing. We will. We're going to do it right now in a minute. All right, get back to this. So it's an anion, it's negative. What does that mean we have to do? So guys, look up fluorine's electron configuration. What's fluorine's normal configuration? 2-7. Now, I've got an ion here. It's negative. Negative means what? We add one. So really, what's my configuration for this ion going to be? You guys got that. So go ahead, draw your diagram, and then we'll check it in a second. Nick just asked, when you add it, do you always add it to the last one? Yes. It's always added to your valence number. So always look at that very last one. Everything else inside is stable. It's that last one that's trying to get there. We'll talk more about that when we do bonding. How many protons does fluorine have? 9. What's our number of neutrons going to be? 10, because when you look, they don't give you a mass. You're going to round it to 19 minus 9. Gives us our 10. How many rings will I have? I have 2. All right. How many dots on the first ring? 2. So get in the habit, putting the first 2 together. My next ring is going to have 8. So I'm going to go 1, 2. Then I'm going to do 1. Spread them all out first. Then go back and double up. Now with this one, guys, if you just put them all together, they're all going to be together in the end. And that's fine. Okay. Get in that habit, though, of spreading them out. Doesn't matter the order you kind of start spreading them out in. No. You could start over here and go there and this way. You could go here to there to there. Guys, it's whatever. You'll see me kind of follow. You'll follow in the same type of pattern. I typically will just go clockwise. Okay, but it's really up to you. Any questions? The Bohr stuff, you might see a question, you probably won't. Okay, so just introducing it to you guys, this is what you definitely will see. Lewis dot diagrams or electron dot diagrams, guys. They only illustrate the valence configuration. This is extremely critical when we come back and do bonding later on. This is all we will be looking at, our Lewis dot diagrams. So what we're going to do is just write the element symbol. That symbol represents all of the inner shell electrons or the kernel ones, I should say. That's what the term we used yesterday. and the nucleus. Okay? So it represents the kernel electrons and the nucleus. So again, look at your configuration from the periodic table. The last numbers, your valence electrons. Then we're going to draw the symbol and show that many dots, like we just showed, around the symbol to represent those valence electrons. So for carbon, okay, how many valence electrons, guys, does carbon have? What's our configuration? Right, 2-4. So we don't worry about the inner ones. 4 are the electron dots that we have, or valence electrons that we will represent with dots. Same way we just did. Put the 2 up at the top first, then spread out the last 2. You could do it with dots, or you could do it with X's if you want. It's up to you. Typically you will see dots. They mean the same thing. Remember, if you're working with an ion, you have to adjust that number of valence electrons. Okay? So keep that in mind. Everybody good with this slide? All right. If we take a look here. So, S2 minus, we're going to add those 2 electrons so that the 2 minus always, will add up. How many valence electrons will we have then for the sulfur 2 minus ion? So if we wrote out our configuration, what's the normal configuration for sulfur? 2 dash. Guys, what's our normal configuration for sulfur? 286. So if we add 2 electrons, it becomes now what? 288 would be the ion. Okay. How many valence electrons? Look at that last number. So, sulfur symbol is S. We're going to put 8 dots around it. 1, 2, 3, 4, 5, 6, 7, 8. That's it. Okay? That's all we have to do, guys, for Lewis dot diagrams. We are going to be doing these a whole lot when, like I said, when we get into bonding. Notice, though, negative ions, guys, always end with how many valence electrons? 8. They always will have 8. Why? Because they're getting to that magic number. We'll talk more about that later on. Negative ions always will have 8 valence electrons. Excuse me. Kind of, but not exactly. It is a magic number. I didn't even think about a magic 8 ball. You're the first student in all my years of teaching to ever say that. So I don't know if that's something to be proud of or not. Potassium, guys. What's our configuration for potassium? All right. If we remove 1 electron, what does it become? Now, you might see it written, guys, as 0. Okay? Same number, right? Okay? When we draw a positive ion, now there's one thing I forgot to put here. We have to put that -2 on the sulfur. Why do you think that's important? Exactly. So if you guys couldn't hear Sarah, she said we have to make sure we put that on there because it shows that it's not a normal atom of sulfur. It has gained 2 electrons. If you don't put that -2 there, this would be incorrect. Okay? You got to have that charge there. When we get into bonding and naming, it's going to make more sense. So just keep that in mind right now. So over here we have K+. How many valence electrons now will we actually show? Not 8. 0. Positive ions, guys, always end with 0 valence electrons because they lost their outermost one. All right? So we only have 0. So they will not have any dots around them. This is all they will have is K+. Okay? Questions on Lewis dot diagrams? So,